Okay, so on to 1.5. This snow days without snow. How about that? So we're looking at section 1.3, question number 1.5 rather, question number 11 and 12, that area. And those questions ask about the vertical. It's actually 11 and 12, the vertical line test. So in these questions, you have some kind of squiggly that looks like this versus some kind of squiggly that looks like that. And in this case, you could take vertical lines and pass them through. I'm going to get rid of this axis and this axis so you can see what's going on. And if all those vertical lines pass through the function exactly one time, it's your way of indicating that for each input x, there's only one y value. Now notice it doesn't go the other way around. I can go like that and hit more than one point. That's allowed, but as long as the vertical line test passes vertical lines, we're good. Now, if the picture looks like this, then this doesn't work. Gotta get my lines back. There we go. See, this is bad because why? We have some or all x's have 2 or more y's associated with them. So this would be a good function over to the left, and over to the right is not a function. Okay? So that's what you're supposed to do. That's it. It's a very, very easy question. Okay, so questions 15 through 17 say, find the zeros of the function algebraically. This is exactly the same as the last homework set where we said find f of x equals 0. What are the x's? It's exactly the same thing. Find the zeros is just another way of saying solve. And so you still need to factor, but these factoring questions are slightly harder than the ones we did in the last homework. So, but then this one is a little different. Number 17, it says x over something, right? We want to know when that equals 0. And so you want to, they're actually trying to trick you actually. They want you to factor the bottom and incorrectly solve for when those things are 0. That's not what you really want to do. Only x equals 0 causes f to be equal to 0. Down here, if you solve for 9x squared minus 4, which is 3x plus 2, 3x minus 2, blah, 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 etc., will only tells you when f of x is equal to infinity, plus or minus infinity. So it gives you what's called the asymptotes, and we haven't talked about that in class yet. But this is an important thing you need to do, but it does not tell you when the function is 0. Okay, so that's what your little watch out for number 17. But for 15 and 16, it's factoring as usual. Whether you like it or not, you're going to have to do it a lot, so you may as well get used to it. Okay, next set of questions. Okay, this concept is actually a little bit new. We have not talked about it in class yet, as of whatever today is. Today is Tuesday, January 26th. So I don't know when you're watching this. If you're watching it later, then that comment isn't necessarily true. Okay, so what we're talking about is average rate of change, and it really is the same as the slope of a line. So we have this formula that we already know how to use is the average rate of change. Okay, so if you can accept that, then you really don't have a new concept to learn. But if this is a little bit of a stretch for you, then you have to think of it as a new concept. So let me do question 61, since it's a very similar question and near to that range. So if I say f of x is minus 2x plus 15, and then the x1 is 0 and x2 is 3, then I have to calculate what y1 and y2 are. F of 0 is going to give me y1, which is just going to be 15. F of 3 is going to give me y2. Okay, so we just have average rate of change is y2 minus y1 over x2 minus x1, which is negative 6 over 3, which is negative 2. Okay, that's the average rate of change. That's how you calculate it. And you may say, wait a minute, you did all this work and the number is sitting right there. And you're absolutely right. For a line, you never have to calculate average rate of change for any line. But that wasn't one of your homework exercises. Your homework exercise has a quadratic and a cubic in it. Okay, so I'm showing you the technique because on the homework you can't take that shortcut. Alright, so I know this is the long way to do it. If you were to be asked average rate of change for a line, you would just take the slope of the line and be done with the problem. Okay? Okay, so this is the 71 through 74 range. I want to see what's going on there with those questions. Okay. This is, you're supposed to tell me if the functions here have even symmetry, odd symmetry, or neither. So what does that mean? Even symmetry is very similar to odd symmetry, but it's opposite, so you'll see what that means. And you've seen this stuff before. In fact, we already talked about that earlier in, I don't know, already this semester. But it's a new word for the same concept you already have. If you have symmetry about the y-axis, it's called even symmetry. And in this case, f of minus x is the same as f of x. So if you replace every instance of x with negative x and you do out the algebra and you get back home to the same function, you have even symmetry. If you have this kind of thing going on, you have 180 degree rotation gives you back the same function about the origin, or 0, 0. You can also say f of minus x is going to give you negative f of x. Sorry for all those negatives in the same place. This is equals negative. There we go. That's what odd symmetry is. Okay, so that's what you're trying to determine. In question 71, the way you figure this out is you simply say, wait a minute, all the exponents are even, so we're automatically in this category. So there's a shortcut. Any polynomial that looks like this, like something like that, it doesn't matter if the coefficient is odd, but as long as you could add you can add a constant because it's like x to the 0, which is even. So anything of this structure is automatically even, and anything of this structure is automatically odd if the exponents are all odd. And if the exponents are all even, you have even symmetry. So that takes care of a couple of problems. But then for number 73 and 74, you have to think about that a little bit longer. So I'll let you go ahead and do that. I'll let you replace x with negative x. So in 73 and 74, so you want to, for number 73 and 74, replace x with minus x and do the simplification and see whether you end up, I'll guarantee it's either even or odd. It's not, wait a minute, I could be lying. At least one of them is even or odd. The other one might be neither. I have to think about that because there's a shift in it. If there weren't a shift, then I would be okay with it. But this x times square root of x plus 5, I have to think about that. That might be a neither. Think about that. Yeah, I'm pretty sure that's going to be a neither. But 73 is going to either be either even or odd, and I want you to think about that and figure it out. The other thing you can do with these is you can go to Wolfram Alpha and you can just plot these on Wolfram Alpha, and then if you visually see the symmetry you're looking for, that's a good indicator. I wouldn't do that for question 75 or 76. Because Wolfram Alpha does weird things to those exponents, but we're not doing question 75 and 76. But for pretty basic functions, you can just plot them on Wolfram Alpha and see if they're even or odd. Okay, hope that helps.